All right, now let's see how we can use custom types in TypeScript. So I'm going to start by declaring a function like drawPoint. So this function takes an X and a Y and simply draws it on the screen. Now we don't want to worry about the actual drawing algorithm. We just want to focus on the signature of this function. Now this function is not too bad. Here we have only 2 parameters. But sometimes when working with more complex concepts, we may end up with a function that has so many parameters like this. This is really bad and it's something you should avoid at all times. In those situations, it's very likely that a group of these parameters, maybe all of them, belong to a single concept. As an example, think of a car. A car has so many different properties. We don't want to pass all those properties to a function like drive car. Instead, we want to encapsulate them inside an object and only pass that one object here. So in this example, instead of passing X and Y here, it's better to pass a point object. And then we can call this function like this, drawPoint. We give it an object with 2 properties, X and Y. So now our function has a cleaner syntax. However, there is a problem with this implementation. Instead of a point object, I can pass a person object that has a name property. And nowhere here we're getting a compile time error. But we know that this code is going to break at runtime because the algorithm in our drawPoint function is expecting X and Y properties. So what's the solution? Well, let me revert this back. Okay, we've got X and Y. So there are 2 solutions to solve this problem. One way is to use what we call inline annotation. So just like we can annotate this parameter with a type like number, we can annotate it with a custom type or a custom object. So here we add curly braces to indicate an object. This object is going to have a property called X, which is a number, and also another property called Y, which is again a number. So this is what we call inline annotation. It works fine for simple cases, but the problem with this, as you can see, is that this is a little bit verbose. Also, chances are somewhere else we might have another function that expects a point object. We don't want to repeat this object literal in multiple places. So in those cases, a better approach is to use an interface. If you have worked with object-oriented programming languages like C# and Java, you know the concept of interfaces. We have the same concept in TypeScript. Now, if you have never worked with interfaces, let me show you how they work. So on the top, I define an interface. And I'm going to call this point. Curly braces. Then I add X is a number and Y is a number. So with this interface, I'm defining the shape of an object. And then I can simplify this declaration and set the type of this parameter to point. This is much cleaner, and we can also reuse this in multiple places. Just one thing, note the naming convention I have used here. So because I'm introducing a custom type, I've used Pascal naming convention. So the first letter of every word in the name of the interface should be capitalized. So here we have uppercase P, not a lowercase p, okay? So when using interfaces, always use Pascal naming convention.